A video on solving simultaneous equations. In this course, we've covered a few methods of how to do that. I'm going to cover all of them with this one example. So we're going to end up solving this in 1, 2, 3, 4, 5 different ways. All right, let's give it a try. Now, in the substitution method, you have to isolate at least one of the variables for one of the equations. The easiest one to do that for is probably this one here, the second equation, and isolate the y. So I'm going to take that equation over here. Let me just pull that over there. Let's do that on the mouse. Okay, and I'm going to write that as I'm going to switch the sides of the y by adding y to both sides equals 4 plus y. And then swap the sides, keep the y on one side, and then subtract 4 to x minus 4. So, having done that, we can then go and substitute into the other equation. So if I wrote the other equation here, 5x minus 2, bracket. All right. I'll write the rest of it, equals 7. And I'm going to change color, and I'm going to put the equation in here. Okay, so we've substituted the first equation into, the second equation actually, into the first. So let's carry on expanding that. 5x minus 2. No. Let's expand that properly. 2 times 2x is 4x. Minus 2 times minus 4 is plus 8. Let's group some like terms. All right, we have 1 lot of x. 5 minus 4 is 1 lot of x. Move that 8 across the other side by subtraction. You have minus 1. Easy. Then we need to substitute that back into, I might as well just go put it back into this equation. So if I put it over here, y equals 2 bracket minus 1 minus 4. 2 times minus 1 is minus 2, minus 4 is negative 6. So my final answer is minus 1 minus 6. And I'm just going to check my notes, make sure I haven't made a mistake. Yep, that is the answer I got recorded. So, okay, we've done that one. So we've done substitution. So substitution requires you to isolate at least one variable, substitute one equation into the other, and then solve for one variable, and then substitute that answer back into the other one and solve for the other variable. All right. Let me just clear up the space, and we'll demonstrate the other method. Okay, elimination. Now, these two equations are written in general form. However, you can't use elimination straight away. All right, so we need to, when you use elimination, you need to have at least one term where you have the same coefficient of x or y, and preferably with the opposite sign to make it a bit easier. So, for example, you can see here with we've got minus 2y and positive 2y. What I'm going to do is take equation 2, I'm going to multiply it by minus 1. So take equation 2 times by minus 2, actually. Okay, so what would that be? If I did 2x times minus 2, I'll have minus 4x. And then plus 2y equals minus 8. Okay. Now, if I write the other equation underneath, 5x minus 2y equals positive 7. Now, if I add the two left-hand sides and the two right-hand sides across the equation, I have something that looks like this. So minus 4x. What am I doing? More space. Minus 4x plus 5y plus 2x. Sorry, What am I doing? 5x. What am I doing? Okay. Plus 2y minus 2y. These cancel. You've undone each other. Minus 8 plus 7. And if you add these up, minus 4x plus positive 5y, you have 1 lot of x minus 1. Okay, and then remembering, you substitute that back into one of the equations, and you'll find y equals minus 6. Okay. So that's how you do elimination. Okay. Now, let's redo that. Get rid of all this. Now, just realized I haven't got a grid up for this one, so I'm going to actually pause the video for a moment and come back with a grid. Okay, so now we're going to continue with our solving simultaneous equations. We are going to look at graphing things by hand. Now, if I got, there it is. Let's grab some graph paper. Copy. Back to paint. I can paste that. Let's just leave it as it is. Okay. Yep. So with these general equations, the easiest way to get some points to graph is by using the axis-intercepts. So if I, for the first equation, equation 1, we just let x equal 0, and then we'd have minus 2y equals 7. That means y equals minus 7 on 2, or minus 3.5. All right. For y equals 0, we have 5x equals 7. Divide 7 by 5, x will be equal to 1.2. No, actually, 7, 1.4. There we go. So this isn't the best one for the best method for this set of equations because the numbers are ending up decimals. But it's okay. It will do. Now, for the second one, let me just take another equation 2. And we'll let x equals 0. Then it'll be minus y equals 4. Or yep, 4. And then y equals negative 4. And then y equals 0. 2x equals 4. Yep, 4. And that would imply x. X equals 2. Okay. So, those coordinates there. All right. So those are all the intercepts. And okay, so we need, as far as this goes, we need negative y, and that's positive, so we'll be going up that way. And negative y, and there. Now we already kind of know where the solution is going to be because we've solved this a couple of times. So it's going to be a little bit tricky, but we don't need positive x space. Positive. We don't need positive y space. We need negative x space because we already kind of know what the answer is going to be. So put an axis around here. That's not the best line I could do. You know what? I can use the zoom feature. Zoom. Yep. Okay. So let's draw a line. Yep, line feature there. We don't need a lot of negative space, so let's put that there. Okay, both of my y's are in negative space, so I don't need positive y space. So I'm going to put my axis actually quite up there here in the corner. All right. Okay, so I'm going to put in here. All right, so this can be my spot for -1. It came out a bit larger than I wanted to. Yeah, I'm not doing it that way. Okay, let's write by hand. Okay, so there would be -1, and there would be -2. And that can be 1, 2, 3, 4. My x, that's my y. All right. And we need some y space. I'm going to do. Let's actually draw it out, not all the way down. 1, 2, 3. No, I need more than that. Okay, so I'm going to go -1, -2, -3, -4, -5, -6. And we already kind of know where this is going to be. Even though I zoomed out, those are still going to be very big when I zoom back in. Okay. All right. Okay. All right. Yeah, I probably should have put them on the other side. All right, too late. Let's just do it. Okay, so let's get back to that. Get some colors going on here. We'll do green. All right. Equation 1. All right, that's 1.4. Now, fortunately, we're going to have to estimate this, and this is not the best way to go about it because of the decimals. All right, so you have to draw a much larger axis to get what a green. There we go. All right, so that's about 1.5. 1.4 is there. And -3.5 be in the middle of 3 and 4, which is there. And you can join a line from there to there and continue. Okay, so there's that one. All right, the other one, I'll put that in a brighter red. All right, we have -4. And we have x equals 2. So I might just draw that straight in. All right, so 2. Actually, why did that change color? That's better. Sorry, I want a new line. All right, new line in red. Okay, so we're starting at 2, and we're going to 4. All right, that's not too bad. Those are very similar lines, though. So yeah, we do get the right coordinate. Thereabouts. It's, yeah, the intersection is here. Yeah, which is -2, -6. Okay, so we've done that one. We're all good. All right, so let's tick that one off. All right, now let's remember how to do this on a graphics calculator. In the graphing section, unfortunately, you do have to isolate both equations in terms of y, so that's going to be our first task. Let's just clear this first. Okay. All right, so we've isolated these, one of these at least already. So if I was to bring that equation out, if I switch the x side, I've got 2y equals 7 minus 2x. All right, I'm going to divide both sides by -2, so I end up with, hang on, mistake, copy that down wrong, it's 5x. Okay, so far so good. Divide both sides by -2. I'm going to swap these two around as well. So we'd have 5 on 2, x, and -7 on 2. Second equation. All right. Okay, minus y equals -2x plus 4. times by minus 1, y equals 2x minus 4. Okay, so those are what you can put into your calculator. So go to your TI, go to y equals, let's just make sure we can see them. All right, first one. Whoopsies. There we go. All right, 5 on 2. Could put in brackets. Could write it as a decimal. Okay, 5 on 2x minus minus 7 on 2. Okay. The next one is 2x minus 4. Okay. Let's see how we go. Graph it. Okay, can't quite see it. Change our window. We need enough negative x space, which we have. We don't actually need as much as that. We're going to go reduce the amount of positive x space. We definitely need more minus y space. Change that to 7. We do not need that much positive y space. Okay, so fixing our window, and there we can see the intersection. All right, so we go to calc, intersection. All right, just keep pressing the buttons. There we go. Intersection, once again, minus 1 and minus 6. So that's that technique there. Okay. So done that one too. All right, and we're about to do the last one. All right. Now the last one, you can actually solve them. This is probably the easiest way to solve in this format here, because we have another function on your calculator, simultaneous equations. Now for this one, press the app key. Go to apps, go down to polysmlt 2, and go to the simultaneous equation solver. All right, and you have 2 equations with 2 unknowns. So let's go to, that is the F5 key there. Because your screens have links, these buttons here link to the ones here. So type them in, pretty much type in the equation as written. 5 minus 2y equals 7, and 2 minus, that is 1y, and that one's 4. Okay, and if we solve that, again, same answer. So we've done all the different techniques, and we've managed to get the same answer for all of them. So there you are. Okay, thank you. Catch you next time.